Welcome to linear algebra. So we're going to find the maximum and minimum profit amount of materials or products to be produced, so that we're going to use inequality. So we're going to use inequalities. This is a furniture manufacturer producing tables and chairs, and then the basic types of labor, carpentry and finishing. So it involves two types, which is carpentry and finishing of the woods. And we have 2 hours for carpentry, 1 hour for finishing. And then we have $35 profit per table and $20 per chair. So we need maximum profit. How many should we produce of each? So we start with the table. So in this table there we have so we have the vertex. So before the helix we have the tables and chair. So we're going to say we have these tables, we represented by T, and we have chairs. Let's take the variable to be C. So you can say X and Y, it's up to you, but it's just to be relevant. So available time allocated, so that's the more constraint that we have beside other resources. So we have carpentry, then we have finishing, so carpentry and finishing. So we have finishing there of the material, so the hours spent on each. So finishing, and then we have profit, so the profit we make on each table. So that's our target. We need to know how many tables we need to make and chairs for profit. So tables 2 hours and 1 hour finishing. So 2 hours for carpentry for the tables. So we have 2 hours for the table and then 1 hour finishing for the table. Chairs, we have 3 hours for carpentry and then half hour for finishing. So it's 3 hours and then half hour. And then time allocated per day, so maximum 108 hours of carpentry work. So it's 108 hours that is divided among the workers. And then we have 20 hours there for finishing per day. So per day we have 20 hours. So the time is our main constraint. So we need to know how much we can produce for the time. So it's $35 per table, and then we have also $20 per chair. And then the next thing that we have to do, we need to know the constraints. So the constraints that we have, that's carpentry. So let's go to carpentry and say what are the constraints we have. In hours we have 2t plus 3c, that's less or equals to 108. So that's just in terms of 2 hours on the table, 3 hours on the chair, less than 108 hours, and then 1 table and half chair, 1 hour on the table, half hour on the chair, less than 20. So time is greater or equals to 0, the table is greater than 0, and also chair greater than 0. So that's what we're looking at. We need to look at more tables and chairs we need to produce. Objective function, so that's the objective, like what are we willing to achieve. We need to achieve the profit. So the profit there will be $35 per chair and $20 per table, $35 per table, $20 per chair. So that's going to be 35t plus 20 c. So that's the number of equation there. So subjective, so that's subject to constraint. So the constraint is time, so we need to make that profit under the constraint of time and the allocated time. So we start with that equation there, and then that's going to be 2t plus c is less or equals to 108, and then what is where where g, let's say c is 0, we're going to have 1, we are going to have t is equals to 108 divided by 2, so that translates to 54. So that's actually 54. So 108 divided by 2, 2 into 10 is 5, 2 into 8 is 4, so that's 54. And then the other thing, that where from the same equation where t is 0, so if t is 0, so we need to draw a graph, so we need to know those points. So c is going to be 108 divided by 3. So 108 divided by 3 is going to be 36. 3 into 10 is 3, 1, yeah. And then we have a situation whereby we have a half c less or equals to 20. So that means that we have where, let's say where c is 0, g is going to be 20, obvious. So g is going to give us 20, and where t is 0, and then where t is 0, okay, where t is 0, we have c there. C is going to be 20 times 2. 20 times 2 giving us 40. Okay, so those are the coordinates. And then we need one part. The one part will be we graph, so we need to graph the equation. So when graphing the equation, there's a point of intersection, so we graph the constraints, which is the inequality equation. So that's the graph there that we have. Okay, that's our graph. And then we have this line. Okay, let's look at that equation there. So it's 2t plus 3c, and then t plus half t, so half t, so that's the graph there. Yeah, and then we have that graph. Yeah, so those are the vertices. So we have 10, we have 20 there, and then we have 54, and then we have 36, we have 40, and then that's the shaded area. So that's the area that we need to focus at. So that shaded area there, so we have coordinates, the point of intersection. Okay, so let's take the equations of the two graphs too. So we have that one there, t plus half c. So as we're going to have 20 there, and then 40. Okay, so we're going to have t and c, and then we have t plus half c. Half c is less or equals to 20 actually, and then that one there we have 2t plus 3c is less or equals to 108. And then okay, solving the point of intersection, we have t is equals to 108 minus 3c all over 2. That's for that equation there. And then we have t is equals to 20 minus half c, and that is for that equation there. So we have that equation there that we need to solve for t. So t is equals to t, so the right equations are equals to each other. So that's 108 minus 3c over 2 is equals to 20 minus half c. So multiplying both sides by 2, we have 108 minus 3c is equals to 40 minus c, because half times 2 is 1. And then from there we have constant together. 108 minus 40 is going to be 3c minus c. So we're going to have c is equal to 2c is equals to 68. So 108 minus 40, 68. So divide both sides by 2, we have c as 34. So we have 34 there. So we know the value there of intersection. C is 34. So we have equation t is 20 minus half 34. So half 34 is 17. So 20 minus 17 is going to give us 3. So t is 3. So now we have our coordinates there. And yeah, so we have, okay, let's say that's 0 0 there, but we'll leave it like that. Okay, that's 0 point, that's 0 0. So we also have the coordinate that T is 3 and C is 34. So that's point of intersection, T is 3 and then C is 34. And then we also have C there, another point that 0 is to 36, 0 tables, 36 chairs, and then we also have 0 chair to okay, it's the same thing. So we have there 20, where 20 we have 20 tables, 0 chair, and then we have, so those points are done. The next thing that we do, we take all the vertices, the corners of the shape that we have. So the table for vertices, so we need to sketch that for the table for the vertex. We're gonna construct a table. That's our table there. So we're gonna draw a line, that line, that line, and that one there. And then we have okay, so we have the vertex, okay, and then we have the equation there for the profit, where the profit is 35t plus 20c for chairs, okay, t for tables. Then we start at a point where 0 0, we don't manufacture anything. So what's our profit there? So our profit there is going to be 35 multiplied by 0 plus 20 multiplied by 0. Okay, so our final answer is 0. So we're not gonna make any profit if you don't manufacture anything. So suppose we take the 0 chair, 0 tables, and then 36 chairs. What we have 35 times 0 plus 20 times 36, so 36. So let's do the maths. 20 times 36 is 720. So we write our 720 value there. And then the next part will be the part where we have 20 tables and 0 chair. That's gonna be 20 tables and 0 chair. So 20 tables, 0 chair, that's going to be 35 multiplied by 20 plus 20 multiplied by 0. So that's what we get. So now what we have, we do the maths. 35 times 20, 700. And then we only got 700. So we're gonna make $700 profit. So the options of just making only chairs much more than just making tables. So now we have 3 to 34, that's the point of intersection. That means 35 times 3 tables, and then we have 20 multiplied by 34 chairs. Okay, so that gives us 35 times 3 plus 20 times 34, and all that gives us 785. So it's gonna be $785. So you can see we got more money when we do the last option, which is 3 tables and 34 chairs. So hence 3 tables and 34 chairs, and 34 chairs gives us more profit, and that constraint of time. So that's what we should focus on. So we should focus on 3 chairs and 3 tables and 34 chairs to produce daily maximum profit. So that's how powerful this formula is, invented by some of the economists who are also mathematicians, and these guys just help a lot of companies achieve their profit. So the profit is when they make 3 tables and 34 chairs. That's the final answer. I just want to say thank you so much for watching, and if you have any comments, you can leave below, and then and don't forget to follow or subscribe. And this is your 5D tutor, Black Adam. Thank you so much for watching.